Rockin'. So, sorry for the delay getting started. My brain is not working as fast as my computer, which that happens. I'm gonna turn down. Audio is always a joy on Linux. There we go. Okay. I have way too many audio devices, but yeah, okay. That's solid. I want to check and make sure that this has started going to YouTube because it, generally speaking, does not yet. Looks like it has. So that's great. That's great. And then we can go ahead and let people know that we're going to start exploring some fun stuff. So today we are going to be looking at Dask on Kube on ARM, which I finally got working. Took a while, but that's okay. And yeah, let's go ahead and get started, I suppose. Okay. So, oh god damn it. There we go. That's the button that I wanted. Okay, too many buttons. We are gonna start with the Dask. Oh, there's actually two different. Okay, yeah. So this is just. So we're gonna start with the Dask tutorials, and it's gonna be pretty cool. Yeah, we can already. We're gonna skip ahead to. Yeah, there we go. We're gonna parallelizing code. So let's go ahead and. Yeah, okay. Notebook, there we go. Great. Cool. And we're gonna make a copy of this. And this is gonna be called, instead of testmb, Jupyter example run through on Q on ARM. Part 1. Okay, cool. So this is our standard like setup code, and so what I want to do, kubectl get pods -n dask. Okay, cool. So there's a whole bunch of shit running, and I want to delete all of that because I'm not using any of it. What? Oh, I forgot to. There we go. Let's take it. It's gonna take a few minutes. Maybe? It's weird that it's blocking. Interesting. So this one is stuck in terminating. No? Oh, okay. That's fascinating. That's what kubectl. Ah. Okay. Okay, so this host is down. Probably. Oh, as is probably 10. Well, wait, 102 is up. Okay. No idea why that host crashed. Oh, I was screwing around with some stuff the other day. That being said, let's go ahead and reboot that host. 192. Let's say 3.100. Okay. Okay, so There's like... Okay. Oh, weird. None of these have a known IP address. Wait, why did I disable Discovery Scanner? Fine, okay. Yes. Okay. Anyways, whatever. Oh yeah, now it's got its IPv6 address, but we're still not gonna... Oh wait, yeah. Okay, we are gonna remember that. My brain is made of cheese. Because I want to figure out which port with the right host. Because I didn't label them super great. But from what I remember, we're gonna go services, and then, yep, view leases, and then, okay, F5 is, probably not, okay. Okay, 9C is worker 100, and that is switch port 7, right? Unless there's a, yeah, okay. So I'm gonna go reboot the device that's plugged into switch port 7. Be right back. Ooh, we can try my very fancy rack time. Oh, okay. Give me a second on that. Yeah. Oh, okay. Oh, I bet the GoPro turned itself off. No. Well, let's see. Nope. No success with finding a good video device. Okay, well, whatever. I'll be right back. Promise. I'm just gonna go reboot a machine. Switch port 7. Cool. Cool. Hopefully that was the right machine. Let's figure it out. Well, okay, okay, so it wasn't that one. This one's still not responding to pings. Or more accurately, hasn't run its DNS magic. So I've got the IP address that it's gonna get as a static lease there. So let's go ahead. Okay, cool. So like it's sort of up, but maybe not all the way because DNS. Okay, DNS is working. That's solid. Let's see. Rockin'. All of them are ready. Actually, really... then we'll do xargs, kubectl, delete, dask. Okay, and this will hopefully clean everything up. And now that, cool, run this again. Cool, no resources in the Dask namespace. This actually does remind me, though, that I was having some difficulty running this. So I'm gonna go ahead and background that. And let's go over here. Okay, cool. So we're gonna, so no pods in Dask. Let's close this. Actually, I wish this thing would show the IP addresses like magically, like if it would just do magic sniff sniff. I wonder if there's a setting for that. No, I don't want a VLAN. Yeah, okay, whatever. That's fine. That's fine. Okay. Let's close this. We're gonna go ahead and we're gonna set that we're using the load balancer style deployment. This is important, as we discovered from last time, namely because I am not inside of the cluster. And so we need Dask to create a load balancer. I mean, in Spark, you know, we could also make it ourselves. And we could do that here too, but I don't know what I'm doing here. So the fact that Dask will do it automatically, wonderful. Okay. So it says it's creating a scheduler pod on the cluster, and this may take some time. And we can see we've got a scheduler pod. It's come up, and it's gone ahead and it started these interesting load balance service pods that are going to be used for routing stuff. I'm a little fuzzy on how they work. We'll play around with killing them later and seeing what breaks. But for now, that's good. And then we're going to go ahead and we are going to tell it to deploy in adaptive mode. And now we can see it's deployed a container for doing work in. So that's kind of cool. Let's go ahead and TTL. Cool. Solid, right? Looks good. 6 gigs of memory, 2 threads. Okay, cool. I'll run this. Oh, I haven't run this. Okay. Cool. That looks really perfectly fine. No errors reported anywhere. Go ahead and compute the number 1, and we can see it spun up and terminated a bunch of pods really quickly. So I'm actually really curious for, like, how would I say this? Okay, so I'm curious how license are crashing, how is the auto scaler used? Looking at computing some, I see a bunch of pods spun up and then immediately spun down. Anyways, yeah. Is it possible to be reused? Are there some settings I can play with here? So yeah, I mean, we spun up a bunch of work and then all of the workers went away. Not all. This worker is still here hanging out, our original worker, but a bunch of the workers all went away. And the interesting thing that I find is, like, even if we do a bunch of other things, right? We don't see any more workers being added. Although, interestingly enough, this is taking a really long time in the terminating state. Huh. Yeah, whatever. Okay. Okay. So that's like the very, very basic. Let's go back to, okay, so we've done this part. So this is going to be parallelizing code with Dask.delayed. And so it says Dask delayed is a simple way to parallelize existing code bases or build complex systems, and it'll help us develop an understanding for the later systems. Oh, I am not in the right screen. There we go. Sorry. I was doing the talk screen and I meant to be doing this screen. Anyways. Right. The things that I did want to show is like, yeah, we had these pods come up and then go away really, really quickly. That was kind of a little bit surprising to me. Although interestingly enough, I've like seen the same thing happen in some other things. I don't know if it's a bug because I know that when we do it in Spark, it's kind of a bug. And I'd be really curious if we had the same bug and if there's a reason why, or if they'd have a different approach and it's not considered a bug here. So, there is this delayed documentation. Okay, so yeah, these are, so I think Dask delayed is like designed to be like a really, really core building block. So yeah, and this looks like there's some overlap with this. Okay, so here we go. We're gonna make these two toy functions that sleep. They take some work. They take some time to do their work. Cool, sounds good. And then we're gonna time this. Okay, sounds fine. Perfectly reasonable. Yeah. Yeah, okay. Not particularly surprising, but that took 3 seconds. Now, if we import delayed, yeah, party, and then we go ahead and we do this same thing, but it builds up a graph. Ooh. Okay. But is Z actually computed? This is, yes, but, there we go. This is what I'm curious about. Actually, here's another thing that I'm curious about. If we start this, will more things happen? Like inside of Kubernetes, will we see anything happen? No new pods spinning up. Took 2.05 seconds. Sounds pretty optimal. Okay. Oh, that's reasonable. Okay. Okay, so the other option is to parallelize a for loop. Okay. Interesting. So this delayed sum function. Let's go take a look at how this code was functioning. Yeah, okay. Okay, this makes sense. So I am really curious. I want to see if we can do something that'll get this to parallelize. Like, sorry, use multiple machines. Right? Like that's a bunch of data. All right. Actually, let's start with something smaller. Let's start with 10. And then we can just slowly keep increasing until we see see it spinning up workers. Oh, cool! It is spinning up a worker. That's really interesting. Really interesting. I wish there was a little bit more information about what was going on. But that's, like, I mean, that's okay. I mean, that's, like, it's not a thing that people, I think, actually need. It's a thing that I'm curious about because, like... Okay, cool. Let's compute 1,000 elements. Now we should actually get a bunch of containers coming up. I'm going to just grab this one randomly. Okay, cool. Oh, okay. And now it's actually printing out information. Like it's retiring workers. So that's presumably it scaling down. And so we can see it scaling down the workers. It prints the computed sum, and now it's going to keep scaling down. Yeah, that makes a lot of sense. I'm really curious though. So data hasn't changed, right? Okay, right. And we can see worker process 18 was, yeah. So, yeah. Okay, cool. So that's interesting. Okay, so really we're just down to that one pod again. So what happens if I run this again? We create all of the workers again. And that's because there's no... Wonder if there's a way to say, like... I guess there wouldn't really be a way. Okay, well, that's interesting. Let's actually, just apropos of nothing, delete this pod. Okay, it's deleted. And I'm curious if we'll see any complaints in the logs about that. Right, well, we'll wait for everything to be cleaned up first, of course, because I should have written down what, like, my original pod is, but that's okay. Oh, so there's this pod, which is like my OG worker pod. Nothing in there. And this is my scheduler pod, and I think there might be some interesting things in here. Yeah, cool. Here we go. Here we go. Okay. Although, interestingly enough, no error about the worker that I deleted. Yes, okay. Now if I go ahead and I call total.compute again, it's probably going to cache that value. No, it looks like it's not. Okay, interesting. Interesting. Dask cache. Okay, yeah. Opportunistic caching. Yeah. Interesting. Okay. Hey, mostly playing around with Dask. Just noticed that it doesn't really have caching, which is interesting, as far as I can tell. Yeah. This is kind of, yeah, kind of a problem that we have in Spark, and that's why we introduced caching. That's the thing where, like, similar to Dask, we also build like a computation graph. But like sometimes, like for example, we might want to read min and max at the same time. But this requires that we compute both of them. So two simple solutions. Yeah, neither of those are great. I mean, they're cool, but okay, cool. So there's a fixed size cache levering 2 GB of memory. Ah. Okay, I mean, this is interesting. Yeah, okay. I'm curious. Why? Data caching. Yeah, why at the expression level, and, yeah, any thoughts around caching, thoughts around explicit user caching? So this is interesting. So the fact this opportunistic cache means, and the fact that it's saying that it can cause the RAM to fill up means it's probably only running in one place. And so this is interesting. And I'm really curious because in Spark, caching is a huge deal, and it looks like in Dask it's not. And so that's really fascinating. Oh yeah, there's comparison to Spark section. Yeah. Let's see if there's any reference about caching. So that's how I think. No, nothing. Okay, that's fine. Yeah, yeah. Okay. Oh, let's keep going. So that is fascinating. Okay, so double sleeps is even, returns immediately. And so the sequential code doubles every even number and increments every other one, and then we sum up the results. Okay. Oh yeah, and so the is so okay, yeah. So this makes a lot of sense. And this makes a lot of sense because although actually, I mean, the other option, I'm not sure this would be like, yeah, okay. Actually, yeah, let's try it, you know? Whatever. Let's do that. I'm curious. Let's go ahead. We're gonna go back here. We're gonna set this back to a more reasonable range of 100. Yeah, okay, fine. And then I'm going to cell above. Okay. Okay, yeah. So, yeah, that's fine. Okay, cool. So, you have to photo log compute. Cool. Okay. And so, this is the other thing that I want to try really quickly. I'm going to go ahead and I'm going to do this. We're going to move the is even logic inside. I want to see if it, like, maybe... So it's possible that by doing this... Although, actually, no. So over here in increment... Yeah, increment takes a second. Okay. Right, okay, and then... Delayed compute. Okay, cool. Is this going to take the same amount of time? Or is it going to take more time? Or less time? I'm imagining it's going to be about the same. Oh. Ah, fuck, I forgot to put in a return statement. Well... Although, actually, let's, this is something that's interesting. Let's take a look. Yeah, I mean, this error message, it's... If we scroll to the very bottom, like, this is pretty good. Still a little bit confusing. Let's run it again, now that I put in the return statements. So this is functionally, like, this is the same amount of time. Although, actually, let's... functionally, this is the same amount of time does not actually necessarily really mean all that much, so... I'm just wondering, like, what the overhead is of the computation. Anyways, so let's... Cool. Okay. That's gonna hang out for a while, and we're gonna... Oh! Cool. And then afterwards, we're gonna run total visualize, because I am interested about this. Because, like, yeah, I don't know. Yeah. Okay. Rockin', let's play some more ambient. Okay, cool. There we go. I like having a little bit of ambient in the background. Okay, cool. So now, so far everything that we've done is like, yeah. Cool. So what are some examples of control flow where we can't use delayed? Yeah, that's a really good question. So let's think about this. Where couldn't we delay control flow? Well, I mean, we totally can here, right? Oh, cool. I'm not great at LinkedIn requests, MB, sorry. If you shoot me an email, I'll add you on LinkedIn. I have so many LinkedIn things that it's a bunch of them are spam, and it's just hard for me to keep track of them all the time. Yeah, okay, cool. So, I mean, we totally were able to delay this flow control. So I'm not sure this counts really as what are other examples of control flow where we can't use delayed. Like, I think, I'm not particularly sure. So we can see that, like, this is really interesting. Like, so delayed sum results is a delayed value. And so, like, that works out pretty well. But my guess is, like, one of the examples of control flow where we would have difficulty using delayed is where, like, machine learning algorithms where you need to compute a gradient. But actually, like, right, because I compute the gradient, and then based on what the gradient is, I'm going to launch different tasks. Okay. Parallelizing a pandas group by reduction. So yeah, so far this is relatively simple because, well, we do have different operations here, right? Like, everything is just getting summed together. I would be really curious to see if this sum is getting pushed down to the workers. Because, like, it's a partial aggregate. I'm really curious. How would I test that? Partial aggregates. Normally the way that I test it in Spark is I would just make it really, really expensive. Like, I just allocate too much on an individual node so that it has to be. But let's, how are partial aggregates handled? Yeah, I think they can be. Airflow Dask. Yeah, okay. Apache Airflow Dask executor. Yeah. So, totally doable. And you can schedule Dask jobs with Airflow. So I'm really curious about how partial aggregates might function. How do I load? Yeah. Okay. Yeah. So, yes, from Dask import compute, right. So we're actually, so I think what I want to do right now is I want to answer my partial aggregate question, or I want to try and see if I can answer my partial aggregate question, e.g. And that's going to mean we're going to check out the Dask source code. Because Because like that's how I like to play around with stuff. I also want to check out the auto scheduler. Those are the two things that I wanna play around with right now. While this thing is going on. Okay, yeah. Interesting. A whole bunch of the pods are stuck in the pending state. Yeah. Yep. Pending. So I'm assuming that this is just pending because, like, there's no resources for us to schedule it. Yeah. Okay. Doot. Back off when... Let's go. Yeah, sorry, this is the one. Dynamic scheduler. Back off when resources are not being allocated. Underlying cluster. Okay. Yeah, this is not. So this is fascinating to me. We're retiring workers while we have workers pending, right? Like that. Oh wait, maybe it finished. Maybe it finished. Yeah, let's take a look. I'm confused. But it's all right. I'm pretty often confused. All right, yeah. I was gonna check out the Dask code because yeah. Do I have a fork of this yet? Yeah, I do. Cool. It's probably yeah. It's a wee bit out of date. That's okay. And then we're going to go ahead and we're going to add this as a remote. Cool. So, yeah, let's start playing around. Or let's start poking around inside of Dask, I think would be a more accurate. So I think this is going to be in Dask distributed. Nope. Okay. Oh, shit. Is there a separate Dask distributed repo? No. Okay. There is. Okay. Cool. Gotcha. I mean, at the very least, this makes it easier to track down the code, so that's kind of cool. Although I'm gonna give it a different name so I can, like, figure out what it is, because I work with a bunch of different distributed things. Okay, cool. Cool. Again, here is a whole bunch of stuff. Oh, cool. Here's our worker code. That's probably interesting. Okay. Workers perform two functions. Number of threads, scheduler. So all of the data is in memory. Parameter. Oh yeah, cool. Okay. So these are some of the things that we can configure on the worker. Interesting. Huh. So there's a default lifetime, which means... Okay. Okay. Well, this is interesting. Worker client. There's oh, cool. Oh. Controls an object on a remote worker. Okay, so they have actors too. I want to play with actors in a little bit, but we're not there. Okay. There's things that I want to play with, but oh, yeah. Yeah, I wanted to figure out if they did anything interesting for, like... partial aggregates. Ooh. Okay, so there is... No. Does not look like it. I mean, I could be... No. Yeah. Okay, interesting. Does not look like there's any partial aggregates. So that's interesting. Okay, cool. So now we can talk more about lazy execution. And this is something that Spark does, so we'll go through it a little quickly-ish. Because I work on it day in and day out. Oh, okay. Yep. Okay, so this talks about the different tricks that people do. And so process data that doesn't fit memory by breaking it into blocks and doing task chains. Yep. Parallelizing execution of tasks. Yeah, and moving computation. And yeah, like I was saying, it is a graph engine in a very similar way to how Spark is. And that's, oh, right, we were going to visualize it. This is taking a while to visualize. I guess maybe Dask.visualize isn't designed to be run on... Oh, no, we're still running... Sorry, let's go back. Yeah. Ah, here we go. Cool. Here we go. Custom parallel algorithms on a cluster in Dask. Cool. Load from SQL. Not in parallel. Interesting. Okay. I'm really curious if... How would I say this? Like, why there doesn't appear to be parallel data loading? Right, like, why is there not or maybe we'll get to parallel data loading later. Yeah. That's gonna take a while. Yeah, okay, so I can read that stuff in, yeah. Right. This assumes here that like my data is like in an NFS type system. Oh, I'm curious. Yeah. Doot doot. Files and such. NFS type system. Or yeah. Distributed data loads. Splits. So these are like notes and stuff, just because we're gonna be talking later. Does Dask do typical merge reduce process on the join? I don't know. Do not know. I would not be surprised if it does. We'll probably get to its join explanation at some point. Yep, here we go. Example 1, word count. And here is where we will figure out some stuff. Okay. Yes. Wait, no. This is... Normally one thinks of word count as... counting the words. Yes. Yes. Okay. I don't... Okay, delayed execution. Okay. We will probably get to... So there's probably... We will find something... I'm guessing in the data frame section we'll figure out how they handle joins. This is my assumption. And I mean maybe not. Who knows? Okay. Okay. So Dask bag is a mix of a map, filter, tools, and parallel execution. Okay. Oh, cool. This is starting to look a bit more like the kind of stuff I'm used to in Spark. So a Dask bag is probably like equivalent to an RDD or a partition. Yes. Interesting. Okay. Okay, cool. Cool. Although there's no keys necessarily here yet. But yeah, this is... Oh. I don't have GraphViz installed. Okay, yeah. Okay, cool. Okay. Actually, once again, I'm gonna go ahead. Let's go ahead and take a look at what our situation is around nodes. Sorry, not nodes, pods. Okay, cool. Now I'm gonna... Wait, huh. So, okay. Yeah. So this is interesting. Yep. As I increase the range, it's taking more and more time, which makes me think that it's like actually eagerly computing the range. It's eagerly turning it into a list. Let's go ahead and take a look at the Dask bag code. So that's probably going to be in Dask bag. It's going to be from sequence. And actually, we can hear can hear my fan heating up. Sorry, not heating up, spinning up, which makes me think that it is, in fact, potentially, yeah, it's computing this client side, which is interesting. Yeah, okay. Okay, where is def from? Okay, cool. Okay, what does this do? Okay. Otherwise, okay, cool. Interesting. Doot. Huh. Default partition size of 100 LMs in that bag. Doot. Some motivation. Cool. Yeah. So, like, this is the thing that's confusing me. It's like I'm doing this thing, it's kind of expensive, but as far as I can tell, we're not putting it on any other workers. And that part sort of makes sense. In Spark, we wouldn't put it on the workers until later, and Dask is also lazily evaluated. But it, like, from the fact that this is taking a while to run, it's making me think that this is actually, like, eagerly evaluated. So I'm not super sure I get this. Oh, and it's calling len on the sequence. Oh yeah. Okay, here we go. This is the part where everything goes. Not everything goes. Yeah. That's a good question. The Dask folks have their own opinions about it, and I don't think I'm qualified yet to say when Dask is preferred over Spark. But yeah, this is the interesting line of code for the thing that we're looking at, and so it's getting converted into a sequence, and it's actually the Dask bag is being stored locally, as far as I can tell. Interesting. I'm confused. That's okay, mind you. I'm pretty used to being confused. Why not? Parallelize generators. Bags. So let's take a look. Let's see. Yeah, I don't see any. I need to work on the wording here. Yeah, Dask does sort of have a driver. In our case, we have a scheduler and we have a first executor, and they're both running inside of Kubernetes, and my notebook is talking to them, but the driver is not present on my machine. So in the Spark world, this would be a submission in kind of like a hybrid cluster mode. I think it's pretty cool. I like this notebook thing. I think it's pretty neat. Awesome. Reconnect. And actually, that's one of the things that we're going to simulate in a minute. Is I want to simulate a network failure and see what happens there. Could we parallelize generators with bags? Oh, cool. And we can see here, let's go take a look at reduce by actually, since, yeah, okay. Tools.reduce by. And PySpark combined by key. So that's making me think that it's doing probably something pretty similar. Yep. Combine and reduction. Mm-hmm. Okay. Yep. Yeah, yeah. Yeah. So, okay, cool. So this makes sense. Like, the key by is pretty common. And yeah, so we see here that like in this function. So yeah, let's go ahead and do that, right? Like this is a perfectly oh, yeah, sorry. So we're gonna take is even, right? Sorry, my brain is so we've got this Dask bag that we just created, so we might as well try it and use it. Hello! And then we're going to take this add function, and then we're going to group everything together, essentially into even and odd, and we're going to sum up the results. And let's go ahead and take a look and see what happens when we kick that off. I keep forgetting that I'm not using delayed, and so maybe that's what's happening. Oh wait, no, there's a fold by and then a compute. Yes. So the default is fold by key bin op init, and it is, yeah. So right, and this is the same thing in Spark, because right, like in, though interestingly enough, yeah, I mean, I guess we don't know what the reduction function is, but the part which I'm really confused about is this seems to be being computed entirely locally. And I kind of assumed that that would not be the case. Maybe I'm right, because fold by, right? Am I missing something? Ah. Also, hey Nova. I don't know. I don't know why my fold by isn't, because like, so if it's a, so, okay. Oh, yay, I'm glad. So I'm really confused. Why? this isn't doing at all what I thought it would do, right? Like I would have thought the Dask bag would be parallelized by default, but maybe not. Huh. Yeah, same. I would have assumed this too. Enjoy mountains. Okay, no, it does say that it's retrying workers. Oh, it says it's retiring workers. Okay. So it just took a long time to spin up the work. This makes sense. Okay. Okay. This makes a lot more sense. Okay. Although, oh, huh. There's this error here. Let's go take a look at this assertion that just failed. It's in scheduler. Let's go into Dask distributed. Take a look at scheduler.py. And set it distributed. I think, and then it's look like probably def replicate. Okay, cool. Oh, interesting. Performs a tree copy of data throughout the network individually on each piece of data. I'm not sure I understand. Number of replicas we expect to see within the cluster for us. Yeah. And then the number of workers that can copy the data in each generation. Okay. Oh. So this is how we rebalance the data, kind of, sort of. Okay. So that did not go great. Right, okay, let's go. Okay, yes. And then I'm going to go ahead and call compute on this. This is weird. Like, well, I'm not sure it actually really has does it have randomized access? We haven't, strictly speaking, used that. It's got take. Although, this is weird. That doesn't... Oh, okay, yeah, no, that's fine. That does make sense. Okay. Sorry, my brain a little low on the coffee today. Okay. It seems like Dask bags aren't... How would I say this? It seems like Dask bags... Oh, yeah. I did have 3 shots of espresso earlier today. By the way, Carolyn says thank you for that. And I crashed pretty hard. I need more coffee. Anyways. Yeah. Okay. Oh. So this looks more, I don't want to say reasonable. So, but it looks like essentially like from sequence is Dask's version of parallelize. And I know I shouldn't keep comparing all of this stuff. But it's just a really easy habit for me to fall back into. Hello. Anyways, yeah, okay, cool. So here's how we can, yeah, this is filtering stuff. I mean, this is, yeah, so this is the interesting bits. Okay, and we can flatten things. Okay, this same thing as flat map. Yeah, and so just like in Spark, I'm predicting I could be, yes. Group by is particularly bad. In actual workloads, you would do well to use fold by or switch to data frames if possible. Yeah. And so this is just like in Spark. Whereby group by, it makes things sad. And so that's actually what we're going to do is we're going to make this fail in a way that Spark is totally going to fail. Everything's going to fail on this. But I'm curious to see how the failure is reported. So we're going to group it by is even. And then grouped is a, yeah. Okay. There's like a map value or something, I assume. Map, okay, val map is what it's called. I'm guessing val map from tools. Okay. Let's tools. Okay, no. TLZ. Okay. Where is, oh, whatever. Okay. Oh, right. There was that. There's actually the example of exactly what not to do. Yep. Well, okay, there isn't a val map, but that's okay. We'll just do this. Which is to say, we'll take the group data, we'll do this map, and we will sum. I actually like strong typing. I like Python too. Oh, that's my brain. Oh. KV0, and then I don't like this change in Python 3. I think it's Python 3. And then bad sum dot compute. And this will probably fail. But I'm curious how it's going to fail and what that's going to look like. Interestingly enough, it does not appear to be spinning up any pods, which does not make sense to me. Normally, I would expect this to spin up some pods, but we've seen before that... Actually, this might not fail, because we know that we can compute this list. We just know it's going to be, like, hella slow. Yeah, I think so. Oh, fuck, I don't have GraphViz installed. But I think Visualize would show that to me. Let's install GraphViz. Conda install GraphViz. So fold by is the happy one. That's what we want to do. And yeah. So Dask data frames. Okay. Generally nicer. We can do more interesting things here. Okay. Yeah. That's a lot of packages. But okay, sure. That looks fine. Yeah. So, I mean, that's... Although, okay, wait. So it's making a lot of workers. And the interesting thing is, like, yeah, so we do see this. We see terminating workers while there's pending workers. And so that part confuses me. Terminating workers with pending workers. Confuses me. New, confuses me. Yeah, I mean, so we could totally reduce the parallelism. It's just, I would have, is there a way to have the worker be reused? Right? And it's just like, I get it, but like, maybe it isn't possible. And, worker ID to task. Similar? Anyways, I don't know. Yeah, that's just whatever. Admittedly, like, I'm using this in a bad way. Like, I've asked Dask to do things on my cluster that are unlikely to finish. Oh, interesting. Interesting. And we're starting to see some errors. I'm going to assume that this is probably an error. This is the inside of retire workers. Okay, yeah, that's fine. Wait, did we stop? No, we're still running. Ostensibly. Okay, yeah. We're still running. Makes sense. Yeah, okay, cool. So let's go here. Where are we? What do we want to look at next? Okay. I think we've gone through bags. Larger, yeah, okay. So there's numpy. Here we go, sort of. Yes. Right. So Dask.array. This seems fine. Oh, cool. Yes. Yeah, so Dask.array, that looks... Although, I guess Dask.array gives it an order, and I would expect, huh? Like, is there an unordered equivalent of array? Does that make sense? Oh yeah. I don't know. Actually, I really wonder. This is something that I want to look at. Is there like, there's like a setup cloud, Kubernetes. There's not like a lot on configuring. Right? And that's cool. Um, is there a configuration or tuning guide out there you'd recommend? Yeah, okay, so we can generate a random Dask array. And so DA dot, okay, so here we go. So Dask arrays maybe support what I was expecting to find supported in bags. Oh, there's probably like a from thing, slice from chunks. No. I don't want to go from a regular array. No. Okay, so there's from delayed. No, convert. Oh, to delayed. Okay. Okay. Let's take a look at. Huh. How would I generate? Okay. There was a with Dask arrays. So let's see here. So though this is the thing, like, okay, cool. No. Concatenate arrays along a sequence of access. So I guess I could make a bunch of Dask arrays and concatenate them. Oh, this is confusing me. Okay. Oh, whatever. This is a solid start. Okay, cool. Yes. Huh. I guess my confusion around Dask array is like blocked arrays. Yeah. Okay. So it's a blocked algorithm, that's fine. Yes. I guess, yeah, here's essentially my question with task arrays is how do I make something that is from a generator, I guess. And the answer might just be load it from disk. Because like I don't want one computer to be a bottleneck, right? And if I just generate all of these things and then distribute them, anyways, okay. Maybe Ollie will find more of this in Dask distributed. Because all of these things have been like parallelizing, but not necessarily distributed. So Dask data frames, totally amazing. Get it. Don't want to dive into them right now. Let's go take a look at Dask distributed really quickly. Okay, cool. Yep. So this is okay. So some questions to consider. Legit. But like, yeah, local clusters aren't. Yeah, where would we do that? I don't. Oh, progress. Cool. Oh, nice. Nice. I really like the submit. Let me write this. Do. I really like the future submission approach to async flow. Oh, hey, princess. To async flow. Yeah. Can I submit multiple things? Yes. Can I submit multiple things at the same time? Okay, yeah. Yeah. I mean, today is just we're just going through the tutorials. And that's sort of our limitation for today. But yeah. My brain is made of cheese. So yeah, no, I'm just going through the tutorials today, because that's sort of what I want to see. Yeah, I really like the Futures API in Dask. This is fascinating. Okay, well, let's grab this as an example. Okay, let's interrupt that cell. Let's see. Okay. Okay. Fuck, I probably don't have bouquet installed, do I? Yeah. I think it's pretty similar. I really like I like that it's less blocking. Oops. Okay. Huh. Hmm. Mm. Hmm. Hmm. We start off with a point at 0, 0. Oh, okay, I guess this is the, like, setup code that I skipped over. Okay, whatever. Okay, cool. And name C is not defined. Where is C? What? Oh, C.submit. Okay, so let's go ahead. Above C is client. I don't. Okay, cool. Okay, there we go. This is fucking magical. This is really cool. Rockin'. Holy shit. Let's take a look at how this thing is working. Okay, so what this does, sets up a plot. Okay, we've seen that. We make a bunch of random points, and then as the points complete, are we adding these to the iterator? Yeah, okay, and then we go ahead and we add more points to the iterator. Although, interestingly enough, I think there might be a race condition here. Oh, wait, no, because we're doing this in a single thread. Never mind. So, sorry, the for loop is in a single thread, so there's not actually a race condition. I'm used to the producer-consumer model, and so, like, this whole, like, consume it and then add the new thing, like, shimmer. And then breaking, if there's nothing present, would make things unhappy, but yeah, that's pretty cool. Okay. Oh. This is I like this API a lot. I think this is a really cool API. I think yeah, so it's for each and we're adding stuff back in, and it's just like if I was doing this in a bunch of different threads, like I might have a problem. So producer consumer. Anyways. And I'm just used to doing that differently. But anyways, I really like the future submission approach to async flow. Like this, I'm really fascinated. I wonder what I could do to test out failure here, because like this is really fascinating, and I want to kind of test a failure here. So I think what I'm going to do Yep. We're gonna... Yeah. Sorry. I needed a snack. Yeah. And so I think this is kind of neat. Yeah, let's just keep that at 10. We're gonna give that enough time, so 30 seconds. That's enough time for me to sort of like screw with stuff as it's running. Although, interestingly enough, there's a bunch of pods running now, and they've been running for a while, so that's kind of cool. Ah. Let's take a look at this one. Okay, cool. Yeah. Interesting. Yeah, so the workers are inside of pods. The scheduler creates the pods, and the scheduler itself runs inside of a pod in the deployment that I have right now, but there's other ways to deploy it. So this is interesting. So it looks like we just resubmit. This is anyways, fascinating. Are we going to reuse these pods? Are we going to launch new ones? I think we're probably going to reuse them. Okay. We're going to delete that pod. Okay. Yes. Now, I wonder, is everything going to, like, halt for a while? Sorry. Oh, interesting. Yeah. This is cool. Yeah, the scheduler needs some basic amount of memory and compute. Super cool. So this is super fascinating. So we are able to reuse them. I think. Yeah, confuse me. Maybe related to above. I really like the automated worker bounce at memory usage. Are the keys persisted over? How is that decided? I think this feature is super cool. This feature Because, like, on Spark, like, that's just... Anyways. This is very interesting. So let's take a look here. So I think what we're seeing here is that, like, the connection handling. So when Kubernetes deletes, well, actually, yeah, let's yeah, any consideration around graceful decom. Okay, cool. And actually now, yeah, this is going to take a while. So what happens? This is going to take a while. If I delete all of the pods. Like, not all of them. We're going to leave this one up because it's our OG. Well, actually, no. We're going to delete all of these pods, or not all of them. We're going to delete a bunch of the pods while it runs. And I'm predicting, yeah, so we're seeing a bunch of workers going away. And I think it's keeping track, yeah, of what keys are in memory and what's processing. That's really interesting. But the thing which I'm not understanding is why the pods aren't being relaunched. Right? Like, I would expect relaunch. That's let's say we go ahead. We're gonna add a little bit more chaos. I would expect now the scheduler to kind of freak out. We've lost all the workers. Is it gonna recover? No. Okay. Let's run this again. I'm gonna put this back to 0.1 because I don't want to wait a super long time. Why aren't the workers being recreated? Okay. Goes boom. Why? Okay. Stuff goes boom and does not recover. Is this an intentional design choice? Lost workers do not seem to be relaunched. In general. Why? Yeah, so this is fascinating. Like, it's how would I say this? It's like resilient up until a point. Right, and I think we hit that point. So let's go ahead, let's hit stop. We are going to I'm going to comment out some of the things which are, like, decidedly bad. I'm going to change, yeah, that down to 100. And same thing up here, yeah. Okay, cool. Let's go ahead. We're going to go kernel, restart, and clear output. Okay. Cool, and we see that a whole bunch of things are just going away. Specifically, like, everything's going away as we shut down. And that's really cool. Client disconnect. System restart, eventual timeout. Yeah, anyways, these are notes. I'm trying to use it. I'm loving some things here. Like these two things are just amazing. Like, I want to steal them. Oh yeah, good question. Cool. Okay, yeah. Cool. So let's go ahead. Let's make sure everything's gone. Nothing in the Dask namespace. Great. We're gonna run everything. Cool. Okay. Oh, I should have changed this to more reasonable numbers. Because, like, I don't want a bunch of pending containers. But yeah. I guess actually the other thing that I want to see is, and what else can I ask the client about? And let me think. Hold on. Okay, where did we fail? Okay. I installed the wrong graphics. Damn it. Okay, well, whatever. I don't... Okay, cool. While this is running, we've only got one executor up right now, which that's interesting. Oh, yeah, I don't know. I mean, I just know that there's only one executor because there's only one pod, and these are, or sorry, this is the scheduler pod because this existed. It's the first pod that gets created. The pods that get created immediately after that, all at about the same time, and with SV service load balancer, SVCLB, are all load balancer pods, and then this is my executor pod. So I can configure timeouts, heartbeat interval. Yeah. I can cancel jobs. Close, traverse, gather, yeah. Hmm. The collection of futures, yes, yes. Client.scatter. Hmm. Interesting. There's like a bunch of really useful methods on this client. I can get the worker logs. I can list my data sets. What happens? Yeah, okay, let's go list data sets. Are there any named data sets? No. Okay. Hmm. Ah. On the collection, starts computation of the collection on the cluster in the background, provides a new Dask collection that is semantically identical to the previous one, but it's based off of the future in concurrent execution. So I could then, in theory, I think, delayed? Huh, but this won't split it up even if I do that. Yeah, Is there an example? Oh, yeah, okay. I really want to find out about the stateful actors. Oof. Okay, so it's client.persist is the way that we would do this. So, okay, let's go back in here. Is there an, okay, persist method on client, persist method is on the client, for explicit caching, why not called out in the cache documents? Intended to be a user feature or dev feature. Okay. Let's, yeah, no instances of the word persist. Persist. Ah, here we go. Okay. Here we go. Okay. So this makes sense. Here we go. So this is introduced in distributed advanced features. Okay. Yeah, thanks for joining. Oh yeah, my email is just my first name dot my last name at gmail.com. Oh, you don't. Okay, if you don't have email, I'll look for your LinkedIn. Yeah, okay. Yeah. Okay. Yeah. This is a really good exercise. I don't know the answer to it. So let's go ahead and take a look at client persist. Okay, how is persistence done? Okay. Higher priorities take precedence. Resources. Oh, fascinating. So, yeah, we assert that that's a collection. Oh, God. Okay. Oof. It's been a while since I wrote any. Oh, interesting. There's like a restart function which just like kills everything and bounces the cluster. That's kind of cool. Hmm. I'm curious about something. I'm very curious. So, like the wording here really strongly implies to me then this is the future is going to be okay. Let's take a look. So this goes graph to futures, sure. I'm really curious about how future works. A future is a local proxy to a result running on a remote worker. A user managing future objects in the local Python process. So, okay. I am curious. Do we always bring the value back? Like, is that a thing? Hmm. So when someone calls result, if it's asynchronous, we call underscore result, and we await the state to be not an error state or a canceled state. Otherwise, we call underscore gather. Yeah. So yeah, then we go ahead and we get the data. So we don't necessarily bring the data back. Okay, okay. That's interesting. Well, let's double check. Client.submit. Oh, yeah, no. It's not submit. It is. What was it? Is it scatter? No. Maybe. I think for relaunching dead workers, we need adaptive deployments. Yeah, so we used this is an adaptive deployment. If we go up here, we set the minimum number to 1 and the maximum number to 100. The Helm one, I could totally see that doing something cool. I just didn't. The Helm one seemed a little bit not as easy for me to like play around with because I want to try different configurations. Okay, what was I doing? I was doing here. Okay, yeah. Okay. Okay, cool. Yeah, and so that's cool. Oh no. That's the entire point of a stream. Or not the entire point, but like that's a large part of why I do streaming. That's the dog though, and the dog takes precedence because sometimes he will poop on the carpet if I don't take him out. So we're gonna take a quick Timbit break. I'm gonna take Timbit out for a poop, and then I'm gonna come back and do a little bit more poking, and then we'll probably call it a day, because we're at the 2 hour mark, and that's that's a long length of time. Be back soon. Hey baby, Timbit, come on, let's go. Good boy. Let's go outside. Let's go outside and see if you need to poop. Oh, you're being a tricky little dog who doesn't need to poop, but just wants to go play outside with them. Oh, what do you think? What do you think? Wishing for posting time right now. How do you have to take a break? Whoa. Go to bed. Good boy. Okay, so Timbit knocked it out of the park. He peed outside, and that's pretty great. Still a little wound up though, so he's gonna run around the house. And I am gonna go back to doing interesting things with computers. So I am... Yeah, okay, so this is interesting. So broadcasts, super useful. Okay, cool. I think this is interesting. Because this looks more like sort of what I would expect. Although what I'm curious now is because this future's finished. We don't have the result. I'm gonna go ahead and we're gonna delete this pod. And now I'm going to go ahead and try and get the results. And it says it was canceled. What happens if I print F out again? Interesting. The status changed to canceled. That's really cool. But let's submit a future again. We're gonna... Okay. Finished. Okay, cool. And then we're gonna go ahead and we're gonna go get pods. New pod. And then... Okay. Yeah. Huh. That is interesting. Or at least, I mean, interesting to me in that, like, this is, like, I really like this approach. Although, like, I guess the part that I'm confused about, and Timbit might need to poo because he just finished peeing, and he doesn't like to do those in the same trip. So I'm gonna make a note. Are changed to canceled. Is there a way to automatically review them? Or do I need to move up an API level for that magic to occur? Hello, Tim. Okay, so once again, out of the principle of not having dog poop to pick up from my floor, we're going to take Timbit outside really quickly, once again, and hope he poops outside. So wish us luck on that. We'll do that really quickly. Actually, you know what? This is a good enough stopping point. We've been going at it for, you know, over 2 hours now. I think this is really interesting. I want to play with it some more. Oh, wait, no, there's one more thing I wanted to do. I'll do it when I come back. I want to try introducing a network fault in 2 different places and seeing how that's handled. And so that's going to be fun. Where is the puppy? Okay, it seems like perhaps the puppy was just upset that I was not playing with him, because he is no longer making any sounds. Yes, because he's such a good boy. And he's going to come and join us, because he's a puppy. And puppies are the best. Yeah, Tim Tim. Look. This is what your mom spends her time doing, because she made poor life choices and didn't get beyond a bachelor's degree in mathematics. Or good life choices. My friends that went beyond a bachelor's degree don't seem to be doing anything different. But it's okay. I like computers, and they're a lot of fun, and as much as I joke, they're also the bane of my existence. So, thank you for trying to eat my tea bag, Timbit. That's a very helpful puppy. Such a very helpful puppy. Yes, you are. Yes, you are. Let's make sure people can see just how helpful you are. Yeah, that's the microphone. So everyone can hear your snuffles. Okay. So while that's going on, what was I going to do? I was going to kill something here. Yeah. Those are candy wrappers. I can see why you might be interested in them, but I assure you I ate the candy. Yeah, okay. Yeah, I was going to introduce a network fault and see what happens if I introduce a network fault. And I was going to do this using my handy dandy switch. Except I don't know where this pod is running. So, it is on the Kate's Worker NV2. Not for puppies. These are forbidden snacks. Okay, not where I wanted to SSH to. That's A-OK. O.local. And I think ETH0 tells me I want to see what my MAC address is. So it's BABF. I'll label these eventually. Maybe I'll do that later. So it looks like switch port 4 is BABF. And so we're going to go over here, switch port 4, BABF. And we're going to, sorry, Tim Tim, set its name because I want to be able to find it more easily later. There we go. I hope that worked. And what we're going to do is we're going to turn it off. Actually, we're going to isolate. No, let's just turn it off. That's probably easier. Okay. Well, good boy. Okay, it looks like he's going to try and get down. So I'm going to take him over here so that we hang out together. Lots of fun. Lots of fun. So we've turned off that port. And now... Oh, yes, thank you, Tim Tim. Thank you very, very much. The next thing that I want to do is I want to go ahead and I want to call F again. And F is still finished. Did I turn off the right port? It looks like I did. Maybe it was secretly cached. Nope. Oh. I'm not sure I understand this error message. Okay. Yeah, so this is a connection timeout failure. That makes sense. And the other thing that I wanted to see is, so we're going to go ahead and we're going to re-enable this port. Enable port 4. Let's call it again. Huh. Weird. So that's a little weird. I guess I'm not... Transient network errors seems like they could lead to future loss. As above, is this important, or is it expected that a higher level API will retry? Is there a way for a future to recover? These are weird questions. Introduced network failure. Now it's just canceled. Okay, cool. Well, so that's fun. Oh, the other thing I wanted to try. One more thing. I want to try introducing temporary network failure between my notebook and the remote deployed scheduler to simulate like the event of that I'm on a train in a future where we can once again leave our houses. For now, can't leave my house anyways. It doesn't really matter. Oh, that weird. No, actually, we already did that. Because they are both on NVIDIA too, I think. Yeah, okay, so we already actually ended up doing the simulation, so that's interesting. Let's see. Ooh. Huh. My client went away, didn't it? Ah. Okay, to-do, hold on, double check, when the client is connected as well. So is there a way to reconnect? I guess that's my question. There is actually a underscore. There's a underscore reconnect function. So that makes me think that I like am not supposed to use this, but huh. Okay. Oh yeah, here we go. Here we go. Okay. It says restarting connection, replaying 6 buffered messages. I don't know, but that's not Dask. That's the kernel. Weird. Let's take a look at that. kubectl get pods. That looks like it's running fine. Okay, I guess I don't know. I don't know if there's a way to... Don't want to close the client or restart it. I guess, Yeah, and so then if I print F here... Yeah, okay, that's why it's canceled. So okay, I need to go ahead and rerun this to figure out what's going on over here. But that's okay. I think we made some good progress. It's pretty much almost 5 o'clock. I think we're gonna stop for today, and maybe tomorrow, depending on how much time I have and how Professor Tim Tim is doing and all of those things. I might do a little more, trying to understand sort of the resiliency of Dask and its model. And then I think the next one after that I'm going to do is maybe playing around with data frames, because I'm really interested in seeing how Dask data frames work out. So thanks everyone for joining me, and thank you so much for those of you especially who chatted with suggestions or ideas or questions. That's why I do these things live instead of just like recording them. So thank you so much. Please don't apologize for helping. I really appreciate it. Next time I'll hopefully get my rack camera working again, and then maybe I can even get the outside camera working so you can see Timbit on his adventures. That's going to take a little bit more time though. I got some cables that I got to run for that. So thanks everyone for joining me. It's been a wonderful day for me. And I hope y'all are doing as well as possible in our global pandemic and really, you know, fucked up world in so many ways. So thanks everyone, and yeah, I hope to see you soon. Bye. Oh, like and subscribe? Yeah, like and subscribe for more. That's what people say.